Hi everyone, I'm Matt Horton. I'm an AWS ambassador and community builder. I work at a company called CDL as an architect. CDL is an insurtech focused on the use of data and AI to power digital insurance journeys. I think, like a lot of people who work for a software vendor, GenAI has become a standard part now of building out new features in software. And this ranges from using AI coding assistants, being able to ask questions about software metrics in natural language, all the way through to delivering new features in our software that's powered by AI. And it's this last part that this talk will focus on today. In particular, I'll highlight new emerging risks associated with Gen AI based workloads and cover strategies for testing and securing these workloads using Amazon Bedrock. As this is a talk about reInvent a recap, also I'll highlight some of the latest features announced for Amazon Bedrock, showcasing how they will help you create more effective Gen AI workloads. But let's dive into some of the risks associated with software and Gen AI. The foundation of any successful AI is high quality data. AI must have accurate real world observations, or it's just not going to be very good. Often it's tempting to jump straight into the trendy new AI components of a solution without checking that the data it relies on is sound. Another risk I've found is ingesting the world and building an AI monolith. When it comes to agent architecture, I found that small is better, and it's been more effective to build small, focused agents rather than a single large monolithic agent. The agents, of course, can be choreographed to interact with each other to form a larger system overall. And this microservices type approach offers improved modularity and maintainability, easier testing and debugging, and also the flexibility to use different foundational models for specific tasks. And this point can also tie up with misinformation. Given a broad ingest of information from, say, like a company intranet site, it's easy to spread misinformation, either maliciously or more often just by accident. How often are company intranets always up to date with the latest information? Examples I've found is people keeping old copies of, say, like company policies in archive folders. So instead of ingesting the world and hoping for the best, make your AI focused around a smaller, high quality data set that has human oversight to build out trust. You can then use content moderation policies, fact checking procedures, and collaboration with human experts, and this will help prevent the generation and spread of misinformation. With companies keen to be seen to be adopting AI, we can also jump straight in without first defining what success looks like. To measure the effectiveness of your AI agent, it's essential to define specific evaluation criteria, and these metrics will help you assess performance, identify areas for improvement, and track progress over time. Consider the following kind of key evaluation metrics. First is response accuracy. This metric measures how your response compares to your actual ground truth data. It provides information such as if the answers are correct and if the agent shows good performance and high quality. Task completion rate. This would measure the success of the agent. The core idea of this metric is to measure the percentage or proportion of the conversations or user interactions where the agent was able to successfully complete requested tasks and fulfill the user's intent. Not unusual in software development, we often focus on latency and response time, and this is no different for AI. So, this would measure how long a task took to run and the response time. So, essentially, it measures how quickly the agent can provide a response or output after receiving an input or query. And you can also set intermediate metrics that measure how long each step of the agent trace takes to run and identify the steps that need to be optimized then in your system. You could also have things like engagement. So this would measure how well the agent can understand the user's intent, provide relevant and natural responses, and maintain an engagement with a back and forth conversational flow. Conversation coherence is a metric that measures the logical progression and continuity between the responses. So it would check if the context and relevance are kept during the session overall. For example, if appropriate pronouns and references are used throughout. Furthermore, you should also define your use case specific evaluation metrics to determine how well the agent is fulfilling the tasks for your particular use case. So take a HR use case, for example. A possible custom metric might be the number of tickets raised with the HR team because the questions that are being asked, the agent is unable to answer it by itself. But essentially, implementing a robust evaluation process involves creating a comprehensive test data set based on your ground truth data, developing automated evaluation scripts to measure these quantitative metrics, implementing A B testing to compare different agent versions or configurations, and establishing a regular cadence for human evaluation. Evaluation is also an ongoing process, so you should continuously refine your criteria and measurement methods as you learn more about your agent's performance and user needs. So let's address a key question, and this is data. Is your business data actually ready for AI? Unfortunately, for most companies, the answer is going to be no. Indeed, research shows that 85% of all AI initiatives will fail due to inadequate data preparation. Without good inputs, your artificial intelligence investments will not generate a positive return. So, what's data preparation in AI? This means collecting, cleaning, labeling, and transforming data to make it ready for an AI model training and analysis. And this is a crucial step to ensure the accuracy and effectiveness of AI systems. This process is achieved through data pipelines that pull data from multiple sources, prepare it for analysis, and ultimately processing by AI. Data preparation is crucial as it forms the foundation for accurate, interpretable, and efficient AI systems that drive organizational success. Even if you're relying on models that have already been trained well externally, it's crucial to ensure that the data you feed those models for analysis is clean and accurate to get useful outcomes. Bad data leads to poor AI decision making, creating a disaster potentially for your organization. In terms of our architectures, good data engineering principles and tools are key. So let's step through what they look like on AWS. This diagram is from the PEX 309 talk that I co presented at reInvent in 2023, but it's still really relevant today. So typically, applications that are producing our data get broken down into microservices, and then each microservices will use an appropriate tool. So, for example, in the transaction end, you now have an array of different databases for particular use cases. You might have streaming data, and there's purpose built databases to handle that. Customers typically are going to use a larger set of use case specific integration services to flow data between the different transactional and analytical data stores. Within AWS Glue, there are features to baseline and improve data quality, which is really important for AI. The analytical solutions would also use a larger set of purpose built services. And you also might be modernizing with AI and ML to build models for prediction with data that's landed in your analytics areas. You can see that we're dealing with a larger spectrum of services, but to be clear, customers don't have to use all of these services all the time. In fact, most people are going to focus on foundational services like DynamoDB, Aurora, Athena, etc. I also wanted to point out that once you have your data, it's only useful if people can access it in a frictionless way. And of course, this has to be balanced with security and governance controls. And this is where a service like Amazon Data Zone comes in. DataZone is a data management service that makes it faster and easier for customers to catalog, discover, share, and govern data stored across AWS, on premise, and third party sources. With DataZone, administrators and data stewards who oversee an organization's data assets can manage and govern access to data using really fine grained access controls. And these controls are designed to ensure access with the right level of privileges and context. DataZone makes it easier for engineers, data scientists, product managers, analysts, and business users to access data throughout an organization so that they can discover, use, and collaborate to derive data driven insights. AI itself can also help with data discovery and quality, profiling data and ML using AWS Glue, for example. And within DataZone, generative AI features help describe datasets and metadata to speed up the process of cataloging data. Let's look now at another AI feature that specifically enhances the processing and retrieval of data. So this slide shows the data processing features introduced into Bedrock during the AI keynote at the last reInvent. Bedrock automation is in preview, and it's a fully managed capability of Bedrock that streamlines the generation of valuable insights from unstructured, multimodal content such as documents, image, audio, and video. With data automation, you can build automated, intelligent document processing, media analysis, and retrieval augmented generation workflows quickly. Insights include video summaries of key moments, detection of inappropriate image content, automated analysis of complex documents, and much more. And you can customize the outputs to tailor insights into your specific business needs. It can be used as a standalone feature or as a parser when setting up a knowledge base for RAG workflows. So we're going to have a look at a demo now of data automation in action. Okay, let's move on to testing. When we're testing our generative AI systems, non deterministic refers to an inherent challenge where the same input can produce different outputs on repeated runs. And this makes it difficult to reliably test and verify the system's behavior due to this unpredictable nature. Essentially, you can't always expect the same result, even with the exact same prompt. And this is a key characteristic of most Gen AI models. So the key points to consider here are the challenges with traditional testing methods. So standard testing approaches that rely on predictable outcomes, they're not well suited for Gen AI due to that non-deterministic nature. Um, what is more important is the human evaluation. So assessing the quality of Gen AI outputs often requires subjective human judgment to determine if the response is appropriate, relevant, and aligns with the intended purpose. There are a few things that you can do to address this non deterministic testing challenge, though, when you're working with Gen AI in your software. So, first of all, use statistical analysis, and this is running multiple tests with the same input and analyze the distribution of the outputs to understand the range of possible results. Um, Develop quality metrics to measure different aspects like the output coherence, accuracy, relevance, and any bias to assess quality, even with variations in the responses. Data diversity is also important, so it's important to use a wide variety of input prompts to test the model's ability to handle different contexts and situations. You should have monitoring and feedback loops that continuously monitor the performance of the model in real world scenarios and then use feedback to refine the training data and improve the accuracy over time. And use intent based testing. So, this is where you focus on evaluating whether the output aligns with the intended meaning or purpose of the prompt rather than just checking for an exact match. So, let's have a look at how we can use AI to help us with this intent based testing. So here I have a simple piece of Python code. And what we're going to do here is ask a question of an AI model. So we're going to do some well architected type questions. So what is the durability of Amazon S3? And we've had our expert human specify the result there of 11 nines. And we get the result from the first model, and then we will ask a second model to check the output from the first model alongside the expected result and assert whether they mean the same thing. So we can see here that the first model correctly said S3 has 11 nines of durability, and the second model has matched that against the expected result provided by the human and qualified this as a pass. So another item I've been working on recently with the team at CDL is assessing our existing tools such as logging, monitoring, and observability to check that they provide the required level of support for GenAI features in our software. So for this, we built out a sample GenAI workload that was non-sensitive in terms of the data it used, so that we could run this workload at any time and check how our existing tools reacted. So I'll run through a demo of this sample workload. I'll first show the AWS native tooling, and then I'll move on to other third-party options in the monitoring space for supporting GenAI. So here we have our sample workload. Again, we've based it on well architected. So in the background, we've created a knowledge base containing the PDFs of the well architected framework and the supporting resources that are available on the AWS website. And we've set up a number of questions in our sample app based on common kind of well architected questions that we hear when we're assessing our own architectures. Um, and in the sample application, we're doing a number of API calls essentially to the Bedrock service. So we might be invoking a model directly, we might be applying a guardrail, and we might be using the Converse API, and we're doing RAG workflow here. So retrieving information from the knowledge base and processing this. So the standard out of the box dashboard for Bedrock that comes with CloudWatch, you can see the workload kicking in here and running for a few minutes now. The invocation count shows the calls to the different models. So we're using some Anthropic models there, and also the Amazon Titan models. You can see the latency broken down by the different model types, the input token and output token counts, and then the token count by models as well. So letting the workload run for a few more minutes. The only thing that's not populated is the two boxes at the bottom. So those are throttles and error counts. So we weren't throttled during this test run of the workload, and we didn't receive any errors either. But rest assured, if we did, those graphs would be populated out of the box without any settings needing to be changed. And you can see the workload just carrying on in the background. So we run this for a good few minutes and test any tools that we need to. So obviously there we saw the native AWS CloudWatch capabilities, which are pretty good. Um, but we're also assessing our third-party tooling. So for this, we looked at something called Open LLMetry. So this supports AI model observability by capturing and normalizing key performance indicators from diverse AI frameworks. It utilizes an additional open telemetry SDK layer. um, the reason why we looked at this is that we use Dynatrace, so we were already using OpenTelemetry as part of our Dynatrace tenant. Um, so OpenTelemetry, although its auto instrumentation provides valuable insights, it does fall short in capturing specific KPIs that are crucial for AI models, such as the model name, version, the prompt, the completion tokens, and things like temperature parameters. So this is where OpenLLMetry bridges the gap by supporting popular frameworks like OpenAI, Hugging Face, and LangChain. So because the data um, effectively seamlessly integrates with our Dynatrace environments, our users can analyze LLM metrics across the spans and the logs in the context of all the different traces and code level information that we have already. And it supports also a number of other third party tools, so things like Datadog, Honeycomb, New Relic, ones that you see often associated with AWS type workloads. They're also claim to support this open LLMetry feature too. So this is a trace in Dynatrace. It shows our workload running and the standard distributed tracing features that you get as part of Dynatrace picking up the various requests here. So you see it mapped onto our sample workload. So invoking a model directly using the Converse API and applying the using the apply guardrail API also. If we dig a little further into the trace, you can see here a particular um, API call. So it's using the Converse API, and you can see the actual input there, um, which is the question asked as part of the RAG workflow. The model being used, which is the Anthropic Claude 3 Sonnet model. Um, so yeah, it's picked out all of that information. Moving on, as another example trace here, so we're invoking the model directly. So you can see populated are these GenAI um, fields on the right hand side. So we've got the full um, content there that was generated by the AI and the prompts from the user, um, and overall how long this took to complete. So this is really good information if you were looking to optimize the Gen AI features in your software. Okay, let's move on to guardrails. This is a feature again in Amazon Bedrock that you can implement safeguards in your generative AI applications that are customized to your use case and responsible AI policies. You can create multiple guardrails that are tailored to different use cases and then apply them across multiple foundational models, improving end user experiences and standardizing safety controls across the different generative AI applications that you have. You can use guardrails with all the large language models that Bedrock supports, including any fine tuned models. Guardrails offers safety protection on top of any native capabilities of the foundational models that you're using. So this helps customers block more harmful content than the native protection provided by some of the foundational models. Guardrails sits in between the application and the model, and it automatically evaluates everything going into the model from the application and then coming out of the model back to the application to detect and help prevent content that may fall into restricted categories. So here are some of those categories. Things like content filters. This is where you can configure thresholds to help block input prompts or model responses in natural language containing harmful content such as hate speech, violence, misconduct, including criminal activity. and also prompt attacks. Um, so, for example, an e-commerce site could design its online assistant to avoid using inappropriate language. You could also have a list of denied topics. For example, you might have a banking assistant that is designed to avoid topics relating to investment advice. You could also have word filters, so a set of custom words or phrases that you want to detect and block in the interaction between your users and the generative AI applications. So, for example, you might want to detect and block um, a bespoke kind of profanity, as well as specific custom words such as like competitor names or any other words that you may deem offensive or inappropriate. You can also have sensitive information filters. So, this is where you can detect sensitive content such as PII in various standard formats. You can also use custom regex entries. Um, you can do this based on your use case and you can reject information um, containing sensitive information, or you can choose to redact it in the foundational model responses. So, for example, you could redact users' personal information while still being able to generate summaries for customer and agent conversation transcripts. You also have contextual grounding checks. So, this is where you can detect and filter hallucinations in model responses if they're not grounded, so factually inaccurate, or they're just making up new information, or they're just irrelevant to the user's query. So, for example, you can block or flag responses in RAG applications if the model responses deviate from the information in the retrieved passages or they don't answer the question posed by the user. Prompt attacks help you detect and filter things like prompt injection. So, this helps detect prompts that are intended to bypass moderation, override instructions, or generate harmful content. And finally, image content filters. You can use these to detect and filter toxic or harmful images, both in the model input and output. And you can set a filter level for several different factors here and adjust the filter strength. So we're going to have a look at some code level demos of these guardrails in action. Again, we've got some simple Python code here. The first piece of code is actually creating the guardrail. So in this case, what we're doing is we don't want the user to be able to discuss what we're deeming as high risk or perceived high risks in insurance. So things like credit history, crime, past claims, for example. So we're creating this guardrail to stop that type of conversation. So here's the guardrail being created. We use this ID in the next step. The second piece of code is very simple Q&A. So we're asking one question, which is the police have arrested me for smashing a window. Will this affect my car insurance? And um, we obviously want to block that type of conversation. So we've added the ID of the guardrail that we created in the first step, and we'll just run this piece of code now. As you can see, the guardrail has intervened, which is great, and we also were able to output a bespoke message saying that the query may relate to high-risk policy details, so this is best handled by a specialised human agent. And you can customise that message as you see fit. So at reInvent, we got new multimodal toxicity detection with image support. It's in preview. Again, inside Bedrock guardrails. So this is a new capability that detects and filters out undesirable image content in addition to the text that you saw in the previous demo. And this helps you improve user experiences and manage model outputs in your generative AI applications. You can now use existing content filter policy in guardrails to detect and block harmful image content across categories, again, such as hate speech, insults, violence, etc. And you can configure the thresholds with a kind of low to high grading to match your application's needs. So we're going to have another demo here now. So we've got two images. So think of this as feedback in the form of images. So the first chap on the left here is pretty happy about Bedrock, and the second chap on the right, not so much. Okay, moving on to our final topic, which is model distillation. So, this is a capability, again announced in preview at reInvent, that automates the process of creating a distilled model for a specific use case by generating responses from a large foundational model. This is called the teacher model, and then fine tuning it into a smaller foundational model called the student model. It uses data synthesis techniques to improve response from the teacher model. Amazon Bedrock then hosts the final distilled model for inference, giving you a faster and more cost efficient model with accuracy close to that of the teacher model, but for your specific use case. Um, at reInvent, certainly the supported models were the Amazon Meta and Anthropic models with varying sizes for the teacher and student. So that was a lot of announcements there and ground covered. I hope you've enjoyed the ride along and that you've picked up a few things to think about when working with Gen AI in your software.